Hello everyone, welcome to Lessons with Philip. And today we'll continue on matrices, but today we'll focus on multiplication of matrices. Okay, let's start from scalar multiplication of matrices. We have a lot to discuss. Okay, just follow the class. Okay, scalar multiplication of matrices. Okay, how do you multiply matrix by scalar? Okay, now examples. Let's do some examples. Okay, if you're given, assuming we are given matrix A to be equals to 2, 3, 1, 0, and you have to find Roman figure 1, you have to find, let's say you have to find 2A. Roman figure 2, you have to find minus 3A, and Roman figure 3, you have to find half multiplied by matrix A. Your scalar can be any number, can be integer, can be fraction, can be decimal. Okay? Now, solution. Let's see how we multiply. To multiply a scalar with a matrix, that shows that the scalar will multiply each element in the matrix. Okay, let's start and let's see how. Question 1, we have 2 multiplied by matrix A, and that is equals to 2 multiplied by matrix A is 2, 3, 1, 0. If you do that, that shows that the scalar will multiply each of the elements in the matrix. So we have 2 multiplied by 2, 2 multiplied by 3, 2 multiplied by 1, 2 multiplied by 0. Okay? And this will give us, 2 times 2 will give us 4, 2 times 1 will give us 2, 2 times 3 will give us 6, and 2 times 0 will give us 0. Okay? And that is how to multiply with a scalar. Let's do the other examples. Example 2, we have to multiply minus 3A. Multiply minus 3 with matrix A. That will be minus 3 multiplied by matrix A, which is 2, 3, 1, 0. And that will be equals to minus 3 multiplying 2, minus 3 multiplying 3, minus 3 multiplying 1, minus 3 multiplying 0. Okay? So, and this will give us minus 3 times 2 will give us minus 6. Minus 3 times 1 will give us minus 3. Minus 3 times 3 will give us minus 9. Minus 3 times 0 will give us 0. Okay? Are you following? Perfect. Now, the third examples, we have to find half multiplied by matrix A. And that will be half multiplied by matrix A, which is 2, 3, 1, 0. Okay? And that's the same thing as, this one will not be the same thing as half times 2. Okay? Half times 3. Okay? Half times 1, then half times 0. Okay? And this is equals to, this will now be equals to, half times 2 will give me 1. Half times 3 will give me 3 over 2. Half times 1 will give me half, and half times 0 will give me 0. Okay? That is the way to multiply a matrix with a scalar. All right? Then the next thing I want to explain is, before I explain multiplication of 2 by 2 matrix, multiplication of 3 by 3 matrix, and before we explain the power of matrix, if time permits us today, can we quickly explain the properties? The properties, I've explained one of them now. I've started from one of the properties. One of the properties is you can multiply a matrix with a scalar, which I've just explained. Now, let me just write properties. Properties of multiplication of matrices. Okay? That's the subtopic we want to do now. Okay? Now, the first thing which I've explained is that you can multiply a matrix with a scalar. Number 1. Matrix matrix can be multiplied with scalar. Okay, which I've done, e.g., if B equals to 1, 2, 3, find 3B. So my 3B will now be equals to 3 multiplied by matrix B, which is 1, 2, 3. And that's equals to 3. 3 times 1, that is 3. 3 times 2, that is 6. 3 times 3, that is 9. Okay? Now the second properties of matrix is that matrix, multiplication of matrix, for you to multiply two matrices, they must be conformable. Oh, that's nice. Two matrices can only be multiplied if they are conformable. Okay? The matrices that multiply must be a conformable matrices. Okay, let's explain what is conformable matrix. We'll explain that. Okay, now matrices are conformable. Let me write it. Two matrices are conformable when the number of rows in one matrix is equal to the number of columns in the other matrix. Okay? Okay, when the number of rows in one matrix equals to the number of columns in another matrix, then now we say such matrices are conformable. For example, if I have a matrix, e.g., if I have matrix A to be equals to a 2 by 3 matrix, let's say we have 1, 2, 3, we have 1, 2, 3, we have 3, 1, 0. Okay, this is 2 by 3 matrix, and we have my matrix B to be equals to 1, 2, 3, 0, 2, 4. This is a 2 by 3 matrix. This is a 3 by 2 matrix. Okay, I'm trying to explain that now. So this is a 2 by 3 matrix. This is a 3 by 2 matrix. Okay, now these two matrices can be multiplied because the number of row in this matrix equals the number of column in this matrix. Don't forget, I've explained order of matrix. The first number specifies the number of rows, while the second one specifies the number of columns. Do you remember? Perfect. So you can only multiply two columns when the number of rows in one column equals to the number of column, the number of rows in one equals to the number of column in another. Do you get it? Perfect. So now these two matrices, matrix A is said to be conformable. Therefore, matrix A is said to be conformable with matrix B. Okay, somebody saying, what about 2 by 2? Can I multiply 2 by 2 with another 2 by 2 matrix? Yes, because if you have a 2 by 2 matrix, you can multiply it with another 2 by 2 matrix because the number of rows in one equals to the number of columns in another one. Do you get it? All right, before I leave this second principle of matrix, let me tell us that if you multiply AB matrix, if you multiply A and B, matrix AB will give us a 2 by 2 matrices, okay, 2 by 3 matrix rather, 2 by 3 matrix, and matrix BA, if you multiply B times A, it will give us 3 by 3 matrix. Okay, somebody saying, can you prove that? Oh, is there time to prove that? All right, let's prove that. Let's prove this. If you multiply A and B, it will give us a 2 by 3 matrix. If you multiply your BA, it will give us our 3 by 3 matrix. Oh, can we use this example, or can we just finish the principles? Just take note. In our coming examples, we're going to prove that. All right? Can I clean this aspect? Okay. All right. Can I clean the remaining, please? All right. Now, the third principles of matrix. All right. Multiplication of 2 matrices are not cumulative. Okay? Are not cumulative. All right? Multiplication of 2 matrices are not cumulative. What do you mean by that? All right. Assuming, let me give an example. You know, when we did addition of matrices, we said if you have A plus B is the same thing as B plus A. Do you remember? Now, for matrices, they are not. A times B, that is, AB is not equals to BA. Let's give an example. If matrix A is equals to, let's say we have matrix A to be equals to, let's say we have 1, 0, 2, 3, and matrix B to be equals to, let's say we have 4, we have 1, we have, let's say we have 0, we have 2, for example. Then can we find Roman figure 1 AB, Roman figure 2 BA? Let's do these examples and let's see. Now, before I move to the multiplication of this multiplication, let me quickly explain. To multiply a matrix, the rows multiply the columns. Okay? It will be simple. Now, if I have a matrix A to be equals to A1, A2, A3, A4. I quickly want to explain the logic behind multiplication of matrix. And we have B to be equals to B1, B2, B3, B4. I'm using letters so that you'll be able to follow the letters. Now, if I want to find AB, my AB will be equals to, don't forget, I'll multiply A1, A2, A3, A4. I want to multiply with B. This is my matrix A. My matrix B is B1, B2, B3, and B4. Now, to multiply 2 matrices, the rows, each of the rows will multiply each of the columns. All right? And in this multiplication, one element will multiply one element plus the second element multiplying the second element. Let me explain. This will be equals to A1 times B1. A1 times B1, okay, plus A2 times B3. That will form the first row, the first column. Now, to form this first row, the second column, that same row will multiply the second column. So we have A1 multiplied by B2. We have A1 multiplied by B2, okay, A2 multiplied by B4, plus A2 multiplied by B4. Okay? Now, what I have done to the first row, I will do to the second row. So this second row will do the same thing to the two columns I have here. So I have, now I clean this so that this will not confuse you, right? Now, this second row will do the same thing to each of the columns. So we have A3 multiplied by B1. So we have A3 multiplied by B1 plus A4 multiplied by B3. A4 multiplied by B3. Okay, that is the second row, element of the second row, first column. All right, now this row will multiply the second column. So we have A3 multiplied by B2. A3 multiplied by B2 plus A4 multiplied by B4. So we have A4 multiplied by B4. This is the logic. This is the logic in multiplying two matrices. And that's the same way I will use to multiply this. Let's use that method, this logic, to do this now. Okay, Roman figure 1. My AB will now be equals to, what is my matrix A? My matrix A is 1, 0, 2, 3. And my matrix B is 4, 1, 0, 2. Okay? And this will now be equals to 1 times 4. The row will multiply the column. So I have 1 times 4 plus 1. Don't forget, we're going like this. We're going like this. 1 times 4 plus 0 times 0. 0 times 0. Okay? To form the second column, okay, that row will multiply this second column. 1 times 1, we have 1 times 1 plus 0 times 2. 0 times 2. Do you get it? Perfect. So we'll go to the second row. So this one will multiply this column 1. So we have 2 times 4. We have 2 times 4 plus 3 times 0. 3 times 0. Okay? Now, we'll use it to multiply. That same row will multiply the second column. All right? 2 times 1. 2 times 1 plus 3 times 2. 3 times 2. Bracket close. If you check, you see that in my bracket, I'm having 4, 4, 0, 0, 1, 1, 2, 2. What is in the bracket is same. You see, the tallies. So that's just the way to do it, so that when you make a mistake, you can be able to correct that straight away. All right, let's go on. Then if I clean that and I continue, okay, now from here now, 1 times 4, 1 times 4, that is AB, okay, will now be equals to 1 times 4 is 4 plus 0 times 0, okay, 0 times 0 is 0. 2 times 4 is 8 plus 3 times 0 is 0. Okay? 1 times 1 is 1 plus 0 times 2 is 0. 2 times 1 is 2 plus 3 times 2 is 6. Can I continue? Right? That shows that my A plus B will be equals to matrix 4 plus 0 is 4, 8 plus 0 is 8, 1 plus 0 is 1, 2 plus 6 is 8. Take note. Let's do the second one, which is I'm asked to find BA. What will be my matrix B times matrix A? Matrix B is what? What is matrix B? Is 4, 1, okay, 0, 2. Okay, multiply by your matrix A. What is your matrix A? 1, 0, 2, 3. Okay, 1, 0, 2, 3. Now, how do we do that? What you do is you open your bracket, the row will multiply the column, will multiply the first column, and that will be 4 times 1 plus 1 times 2, 1 times 2. Okay, that same row will multiply the second column. Okay? And the second column is what? 4 times 0, that is 4 times 0 plus 1 times 3. 1 times 3. Okay? Now we'll go to the second row. The second row is this. 0 times 1. That will multiply the first column first. That will be 0 times 1. 0 times 1 plus 2 times 2. That is 2 times 2. And that will multiply, will go straight to the second column. The second column, that will be 0 times 0 plus 2 times 3. 2 times 3. Okay? And that will give us, can we open the bracket? Let's do the multiplication. 4 times 1 will give us 4 plus 1 times 2 will give us 2. All right? 0 times 1 will give us 0 plus 2 times 2 will give us 4. Okay? 4 times 0 will give us 0. 1 times 3 will give us 3. That is plus 3. 0 times 0 will give us 0 plus 2 times 3 will give us 6. Okay? If you add this, you get 4 plus 2 will give us 6. 0 plus 4 will give us 4. 0 plus 3 will give us 3. 0 plus 6 will give us 6. If you check this, this is my B plus A. Okay? If you check this two now, your B plus A is 6346. Your AB is 4188. Are they the same? They are not the same. And that is what we have done. That since you could see that my AB, is not equals to my BA. Okay? Do you get it? Let's move on to the fourth. Let's go to property 4. Property 4. Let's go to the property 4. Allow me to clean the board, please. Okay? All right. Let's go to the fourth properties of multiplication of matrices. Number 4. Multiplication of matrices is distributive over addition. Okay, let's see. Supposing we have matrix A multiplied by B plus C, and that's equals to AB plus BC. Sorry, AB plus AC. It's very simple. Just like when you have your A into bracket X plus Y, that should be equals to AX plus AY. Okay? And that's just similar. It's just the same. A times B will give me AB. A times C will give me AC. Okay? That's just similar. Okay, let's confirm. Examples. Okay? We've been doing multiplication. Okay? That all the examples we are doing is still part of multiplication of matrices. Okay? If you are giving matrix A to be equals to, assuming you are giving matrix A to be equals to 1, 2, 0, 3, and you're giving your matrix B, and your matrix B is equals to, let's say we have 0, we have 4, we have 1, 1, and you're giving your matrix C to be equals to, let's say we have 2, we have 0, we have 3, we have 1. Find AB, Roman figure 1. Supposing we have to find Roman figure 1 AB. If it has to find AB, Roman figure 2, if it has to find AC, Roman figure 3, if it has to find A into bracket B plus C. Let's see what we can do. Okay, let's start solution. Okay, now if you want to find AB, my matrix AB will be equals to, what is my matrix A? That is 1, 2, 0, 3. Multiplied by my matrix B is what? 0, 4, 1, 1. And this will be equals to, my AB will be equals to 1 times 0. We have 1 times 0. That is 1 times 0 is 0. Okay? 1 times 0 is 0 plus 2 times 1. 2 times 1 is 2. Okay? 1 times 4, that is 4. Plus 2 times 1, that is 2. Okay? Then we have 0 times 0, which is 0. Plus, okay? 3 times 1. Okay? That is 3. 0 times 4 will be 0. And 3 times 1 is 3. Okay, and that will be equals to 0 plus 2 will give me 2. 0 plus 3 will give me 3. 4 plus 2 will give me 6. And 0 plus 3 will give me 3. That's my A plus B. I'm asked to find my AC. My AC will be equals to, my AC is equals to, what is my matrix A? My matrix A is 1, 2, 0, 3. Okay? And my matrix C is 2, 0, 2, 0, 3, 1. 3, 1. Okay? That will be equals to, don't forget rows will multiply columns. So 1 times 2, which will give me 2, plus 2 times 3, which will give me 6. Okay? 1 times 0 will give me 0. 2 times 1 will give me 2. Okay? 0 times 2, the second row, we want to multiply each of the column now. 0 times 2 will give me 0, plus 3 times 3, which will give me 9. Right? Now, 0 times 0 will give me 0, 3 times 1 plus 3. And that will give me this matrix. 2 plus 6 is 8. Okay? 0 plus 2 will be 2. 0 plus 9 is 9. 0 plus 3 is 3. I've done that 2 examples. Now the third example, I'm asked to find A into brackets, A multiplied by B plus C. Okay? Now, the second example, I'm asked to find A into bracket B plus C. Okay? What is my matrix A? My matrix A is 1, 2, 0, 3. Multiplied by, allow me to use a big bracket to specify this B plus C. Okay? Let me use another marker to specify that. So my B is what? My B is, what is my B? 0, 4. I have 0, 4. I have 1, 1. 1, 1. And my matrix C, my matrix C is 2, 0. That is 2, 0. And I have 3, 1. 3, 1. Okay? Then I close the matrix. Okay? All right. Now don't forget these 2 brackets. This matrix I've specified with this red pen are addition. So I need to solve that. So that will be equals to matrix 1, 2, 0, 3 multiplied by, if I had this, don't forget for addition, you had the element, corresponding element. So 0 plus 2, which will give me, 0 plus 2 will give me 2. 4 plus 0 will give me 4. 1 plus 3 will give me 3. 1 plus 1 will give me 2. Sorry, 1 plus 3 is 4. Sorry. 1 plus 3 will give me 4. All right? So this will give me this. 0 plus 2, give me 2. 4 plus 0 will give me 4. 1 plus 3 will give me 4. 1 plus 1 will give me 2. Now, these two matrices is now multiplication. And that's what we want to do now. All right, I can clean this. Allow me to clean this. Allow me to clean this. I don't want to clean this statement so that we can be able to follow that. Okay. Now, from that, we know that my A multiplied by B plus C will then give me, don't forget, rows will multiply column. And that will give me 1 times 2, which is 2, plus 2 times 4, which is 8. 1 times 4, which will give me 4, plus 2 times 2, which will give me, 2 times 4 is 8. Sorry, that will be 8. Can I start that again? 1 times 2 is 2, plus 2 times 4, which is 8. Then we'll go to the second column. 1 times 4 is 4. 1 times 4 is 4. Thank God I check. 1 times 4 is 4, plus 2 times 2, which is 4. Thank God I check, because if you made a mistake somewhere, it will mess up with the remaining results. So now we'll go to the second row. 0 times 2 is 0, plus 3 times 4, which is 12. 0 times 4 will give me 0, and 3 times 2 will give me 6. So if you find this will give us 2 plus 8 will give us, 2 plus 8 will give us, can we do that? That is 10, this is 12, this is 8, and this is 6. Okay? Now, if you check my AB and my AC, let me confirm. We're now asked to find AB plus my AC. Let's check AB plus AC. What do we have? What is my AB? My AB is 2633 plus my, AB plus AC. Yes, plus AC. What is my AC? That is 8293. And this will give me 2 plus 8 will give me 10. 6 plus 2 will give me 8. 3 plus 9 will give me 12. 3 plus 3 will give me 6. If you check, A plus AC is giving me this. And A into bracket B plus C is giving me this. Okay? Check the answers. 10, 8, 12, 6. 10, 8, 12, 6. Can you see now that my A into bracket B plus C is also equivalent to my AB plus my AC? Correct. That's another policy. That's another property. That's another properties of multiplication of matrices. Multiplication of matrices is distributive over addition. Okay, let's look at, can I clean the board? And let's consider the last, let's call it the last properties of multiplication of matrices. The last properties of multiplication of matrices. I want to clean this fast. I'll be able to clean it well more than this because of time. Right, let's go to property number 5. Now, it says multiplication of matrices is associative. Okay? That shows that when we have, assuming we have A multiplied by matrix B and C is equals to matrix AB multiplied by matrix C. Okay? Now that is the policy. Let's check that properties. Assuming that we have matrix A, a sample. Let's do an example to find out. Assuming we have matrix A to be equals to, let's say we have matrix A to be 1, 0, 2, 3. And we have matrix B to be equals to, let's say we have 2, 1, 1, 0. Okay, and we have matrix C to be equals to, assuming we have matrix to be equals to 4, 1, 3, and we have 1. Okay, assuming this is the matrix where we have these three matrices, and we have to find, assuming we have to find Roman figure 1, A multiplied by matrix B and matrix C, and Roman figure 2, we have to find matrix AB multiplied by matrix C. Let's go. Now, solution. Now, the first one we have to find matrix A multiplied by matrix BC. Okay, that will be equals to, what is my matrix A? My matrix A is 1, 0, 2, 3. And my matrix BC, allow me to put that in a big bracket. I use another pen to specify that. Then what is my B? My matrix B is 2, 1, and we have 1, 0, 1, 0. And my matrix C is what? My matrix C is 4, 1, 3, 1. Okay? Then I close my matrix. All right? Then that shows that my matrix A into bracket BC will not be equals to, I want to deal with the two multiplication first before I multiply with the one. I want to deal with the bracket first. Don't forget, I've taught about order of equations. Okay? Now I deal with the bracket first. Then let me multiply the bracket. Let me open the bracket. So we have my matrix A is 1, 0, 2, 3 multiplied by, what would this matrix that we have in the bracket be? So I need to open this bracket. So don't forget, the rows will multiply the columns. Okay, don't forget. So we have 2 times 4. We have 2 times 4, that is 8, plus 2 times 4 plus 1 times 3. 1 times 3 is 3. Then we have 2 times 1, that is 2, plus 1 times 1, that is 1. Okay? Then we'll go to the second row. 1 times 4, that is 4, plus 0 times 3. 0 times 3 is 0. Okay? Then 1 times 1 is 1, plus 0 times 1 is 0. Okay? And this will give me, let me do the addition. So we have 1, 0, 2, 3 multiplied by 8 plus 3 is 11. 4 plus 0 is 4. 2 plus 1 is 3. And 1 plus 0 is 1. Okay? And when I do this addition, this multiplication, if I multiply these two matrices, then I have, then same principles we used to open this bracket is what we used to multiply these two matrices. So we have, don't forget the rows will multiply the columns. Okay? Now 1 times 11 will give me 11. 0 times 4, that is plus 0. 1 times 3 will give me 3. And 0 times 1 will give me plus 0. Okay? Now we'll go to the second row. So 2 times 11 is 22. And 3 times 4, that is plus 3 times 4 is 12. Okay? Now 2 times 3 will give me 6. Plus 3 times 1 will give me 3. Okay? And this will be equivalent to, 11. 0 plus 11 plus 0 is 11. 3 plus 0 is 3. 22 plus 12 will give me 34. Okay? 6 plus 3 will give me 9. Okay? Let's go to the second question. The second question says, multiply A and matrix B, then you use it to multiply matrix C. Okay? And this will be equals to, what is my matrix A? My matrix A is 1, 0, 2, 3. Okay? And my matrix B is what? Don't forget that is a big bracket. This bracket is what I want to have here. What is my matrix B? My matrix B is what? 2 1 2 1 1 0. Okay, this is my A, this is my B. Now I want to have my C. Okay, then my C is what? My matrix C is 4 1 3 1. Okay, don't forget, this is my matrix C. Then I need to do the bracket first. Okay, that's the order of mathematics. Bracket comes first. Okay, and this is, I use the row to multiply the column. Okay, then 1 times 2 will give me what? 1 times 2 will give me 2, plus 0 times 1 will give me what? 0. Okay, then 1 times 1 will give me 1, then 0 times 0 will give me 0. That's correct. Then we'll go to the second row. 2 times 2 will give me 4, and 3 times 1 will give me 3. Okay, then 2 times 1 will give me 2, plus 3 times 0 will give me 0. Multiply by 4 1 3 1. Okay, now when we go to straight, let me clean this place. I want to clean this. All right, then my A plus my AB multiplied by C, matrix C, will now be equals, I want to do the addition. That will be 2 plus 0 will be 2, 4 plus 3 will be 7, 1 plus 0 will be 1, right? 2 plus 0 will be 2, multiplied by matrix C, which is 4 1 3 1. If I do this multiplication, this will be, don't forget, the row will multiply each of the column in the second matrix. That will be 2 times 4, that will be 8. 1 times 3, that is plus 3. 2 times 1 will be 2, plus 1 times 1 is 1. Then I go to the second column, second row rather. We'll multiply each of the column here. So we have 7 times 4, that is 28. Am I correct? Then plus 2 times 3, that is 6. Okay, now let's multiply the second column. 7 times 1 will be 7, plus 2 times 1 is 2. Okay, and that will be equivalent to 8 plus 3. If you do the addition, 8 plus 3 is 11. 2 plus 1 is 3. 28 plus 6 will be 28 plus 6 will be 34, right? Then 7 plus 2 will be 9. Then this, if you check what you have here, this, if you check what you have here and what you have here, can you see that we have 11, we have 11, we have 11. We have 3, we have 3. We have 34, we have 34. We have 9, we have 9. Can you see that these two matrices, the two multiplications of matrices are equal? Okay, therefore, that satisfy what the properties of matrix. Somebody is saying, is AB multiplied by C, is it the same thing as, can you prove this and send me the result? Is it the same thing as C multiplied by AB? Capital No. It's not the same. Don't forget, we have discussed that in one of our properties. These two matrices are not the same. Now, don't forget, in our classes, in this same class, when we're talking about the properties of multiplication of matrices, we have said that when we have AB, it's not the same thing as BA. And that is the properties that were known as the cumulative properties of matrices. So, we said multiplication of matrices is not cumulative. The same way we have A plus B to be equals to B plus A. It's not the same in multiplication of matrices. So when you have A times B, two matrices multiplying, the matrix is coming first, the one that is coming first, if you interchange, they will not be the same. So you can check this and prove that they are not equal. Okay, so That's just to tell you that these two matrices will never be the same. So in this our confirmation now, AB multiplied by C is equals to matrix A multiplied by matrix BC. Okay, now that is another property of matrices. Okay, I think our time has really gone. Now in our coming class, we're going to deal with the power of multiplication of matrices, the power of matrices. That is very important. The power of matrices. Then we still have many more to do. We have determinant of matrices. Then we use matrices to solve simultaneous equations. I can't but wait to see that. Okay, just kindly follow my class, subscribe to my channel, and like my videos. Thank you so much. Bye.